Okay, it's 10 now, everybody. Are we live? Great, we're live. Hello, everybody. Welcome to BrickRECcon 2025, and we're co-located with IBcon Realcomm as well. So it's a real pleasure to be here today. This session is going to be about 2 hours, and it's a regular thing we do every year. We're covering all of the updates to Brick and RealEstateCore, talking about what some of the guys have been working on and everything that's new with both ontologies. So let's just look at today's agenda. So I'm going to just give a little welcome address and talk about some of the practical things about today, how you guys can participate both in the room and also online. Then we're going to talk a little bit about open standards in general. And then at 10:30, which is 4:30 in Europe, we're going to be doing some demos and then something from the technical committees and finish off with a live Q&A. So as I said, like in terms of housekeeping, please feel free to ask questions in the room. If you put up your hand, I can come around and we can share the microphone so people can hear you online as well. If you are online, I've got the chat open as well, so we can take questions online. And the presentation will be available after the conference. There you can see, if you go to the RealEstateCore website, we'll make sure that it's put up. So today, we've got some presenters. First of all, Gabe from Colorado School of Mines, welcome. Eric Wallin from PropTech OS, and Jason from Mapped. And also we have Carl Hammer from Microsoft, who is remote. I don't know, Carl, are you there?
Yes, I am, Jim. Hello.
Not right now, but he is there, I promise you. Okay. So we can start off by talk about the ROI of open standards. So Eric, if you want to come and join me.
Hi, everyone.
So we recently published a white paper about the ROI of open standards, how using data standards improves the bottom line of real estate, managing real estate, the operation and maintenance phase. So we've got sort of 4 of the kind of key headline ideas and thoughts from that white paper. So maybe you want to start off and talk a little bit about the first one, about communication versus data and understanding that gap.
Yeah, I mean, when we started this out, I mean, we were kind of wanted to, I mean, RealEstateCore, I mean, we're working very close with Brick Schema and gave a special, I mean, it's a long time since we actually started working together. But RealEstateCore was actually founded on the premises of solving the operational problem for property owners, which of course then comes down to also, is it worth spending money on doing this extra work, doing these standards? So we started out just at the end of the last year to get together with Jim. I mean, the thoughts of actually doing a white paper, trying to catch good examples from real life of how you can, I mean, both make sure that you have an ROI, but also how you can calculate the NOI. And I will be talking a little bit about that. But I think if we continue to looking at this, I think the big thing is actually the open standard. I would say now I might be a little bit blunt here, but when you're talking about that you have an open API, which to me means that many times you have a proprietary API which is controlled by someone. And now I'm pointing finger to all vendors possible in the universe with all kind of proprietary APIs. So I mean, one thing that we are really stressing here is to understand what it means to have an API that is shared and that is kind of controlled by something like Brick Schema and/or RealEstateCore, which is a non-profit organization that is very transparent in the kind of standardization making. I don't know, Jim, if I've been covering a couple of your kind of major talking points there, but I guess just stressing that do download the white paper, which goes into depth, and it's actually focusing very much on how you can actually, I mean, convince someone why should we invest money, time and money and resources in this using some standards. It's much easier to just continue as it was yesterday.
Right. So I mean, because the white paper isn't just about the debunking of myths or communication versus data. It's actually real, some concrete information, data on use cases and actually what's been happening.
Yeah. And I think looking at this, I mean, what has been really important for us is actually to maybe not invent and force everyone to speak real estate Korean, but rather to try to work with all other standards. And depending on the kind of property owner, the end user of the standards, they might have some standards already implemented in their buildings, and then it's really hard to make a business case of just updating your tagging or your descriptions because you want to have a standardized or moving over to a new standard. I don't know if I could.
Move it forward. Absolutely.
So, I mean, this image tries to illustrate how we actually see these kind of, I mean, we've been working very closely with Brick Schema, also with ASHRAE, with the 223P, and also with Haystack over the years. And this is kind of, I think you gave first, it was said that was a little bit like a Russian doll that you could see, that you can see. This is of course our vision that, I mean, ASHRAE is kind of standardizing the most intricate control loops in depth, and it's not only the 223P, but I mean the others, the
231P.
Yep.
I don't know all the numbers.
Yeah. I'm more on the other side, and then also, I mean, when it comes to Brick Schema, that is kind of also focused very much on the technical integrators, and then RealEstateCore that has been focusing very much on the kind of adding descriptions for tenants, for contracts, spaces, and other parts. So you actually can use the data into something.
You've listed some vendors there as well. How are they using open standards?
I mean, some vendors such as Schneider Electric and Microsoft are of course using multiple standard, but I mean, together with Microsoft, when they were developing their ASHRAE digital twins, we were doing RealEstateCore together. So I mean, on the ASHRAE digital twins, you can use RealEstateCore directly from Microsoft. And since RealEstateCore, since 1.5, 2 years back, is heavily based on Brick. You're basically using Brick when you're using ASHRAE DTDL. And Schneider Electric has also, since a couple of years, implemented the RealEstateCore APIs, which means that you can plug and play directly. And there are a couple of others, both large and bigs, that are implementing the Brick RealEstateCore and the APIs. Yeah.
Great. Any questions from the audience online at the moment? Sorry. Yeah, let's not get too close. So as part of that white paper, as I said, we didn't just, it wasn't just in a broad discussion about what open standards were. There was actually some real information about what the return on investment is, what the net operating income benefit is. So Eric, let us, maybe you can walk through some of these numbers about what you guys found.
Yeah, I mean, if you're looking at, here's an example, and this is based, the numbers are a little bit obfuscated, but there isn't, I mean, one thing that we have learned is that you can't just buy one system and then you kind of case closed and everything works. It's really a long tail thing. And that's really when it comes in why standards are so important to reuse the data. So you need to use the data from the energy meters for different reasons, for energy optimization, for reporting to tenants or to governments. So this is just an example of how we are calling this. I mean, you're doing the pancake, that you will see that you're calculating the net operational income per square meter and year for different applications, and just adding them, stacking them on top of each other is the way that you can actually make a strong ROI case. And you can follow up. So you can actually validate, and you can validate your different vendors. Now, again, I'm talking from the kind of real estate owner perspective. And here's just some examples of the numbers that you can expect. And in the papers, there are more details, and just in a couple of minutes, I will show you some real customer cases. But I mean, the important point here is that you have to do lots of different efforts, and you will probably, and it's, I mean, you can choose the strategy of going for, I mean, one platform that tries to fix everything, or you can go for the best of breeds. And I wouldn't say that any what's best is depending on the different property owners. But what we see this is that it's usually lots of small efforts that gives the value when you're adding it up. And Jim, I'm just moving over to that one.
Yep.
Because this is kind of a summary, or just a little bit more explanation of this, and that is that it's I mean, this is a typical picture of an independent data layer setup. I know that has been a popular word in over the last couple of years, of how you will have your different data sources, and that you will have lots of different applications that are consuming the same data. I mean, I would say this is, I guess I wouldn't find many opposing this one. This is the paradigm right now, I would guess. I have so strong light here, so I can't really see if you are shaking your head or if you are agreeing with me, but I'll take that as you're agreeing with me. Good. Good. So is it okay that I move over to looking at
Absolutely,
of industry insights?
Yeah. Okay. So we'll take a couple of case studies here. As Eric said, if you're interested in looking at these or in a bit more detail, there is a white paper on the RealEstateCore website. You can download it, and it gives you more information. The first case study is about Howard Hughes Holdings and how they used BrickRECcon25 to enable their sustainability reporting. So very, very interesting kind of use of the open data standards. And Garrick, are you going to talk a little bit about this?
Howard Hughes Holding is a master plan communities is their kind of it's their game, and which means that they are keeping the kind of the larger properties, the retails, the office buildings in the communities that they're building. I think actually the first community, the Woodlands north of Houston, I think they are celebrating 50 years now. So they have been in the business for quite some while. They are, I mean, when they started using RealEstateCore, it was a couple of years ago. It was to automate their sustainability reporting. I don't remember, but it was a huge number of hours that they were spending on manually kind of cut and pasting between different Excel spreadsheets and logging into different systems. So it was and of course, imagine, I mean, the possible error that can sneak in when you're doing it manually. That's where it started. Then they were actually good. I think keep it up a little bit there. Then they were actually also moving over to incorporating more BAS data and IoT data from the different systems. I mean, when they started to see the benefits, but the first case for them was their sustainability reporting. And what they did was that they were using RealEstateCore Brick, I mean the open standard. They also incorporated an HHX innovation division, or I mean, or new internal company within the company. They actually also added blockchain validation to validate the data, but that's a separate business case. We were just looking at how they were using the RealEstateCore, and they, I mean, I was not deeply involved in this, but I had some parts in this, and I know the kind of challenges with having data from so many different kinds of. Here, it was not a challenge just to collect data from BAS system. It was collecting data from the different utility systems, from doing carbon inventory, from all the kind of all their cars that they were using internally, and for everything else. It was vast amount of different data sources that really came from different domains, which made it really, really challenging. And also, I mean, trying to quality assure the data. They took and they got the sustainability reporting, but they're doing, for example, GRESB automatically. They're also put together different kinds of packages, such as IoT packages, or I mean, kind of for things such as water leakage detection. I think we have an example there. And as you can see, they managed to go from a 6 months lag time to almost close to real time when it comes to the sustainability reporting. And also that you can not just do sustainability reporting to comply with governmental regulations or with the market, but actually feed it back to the people working in the building, so they can actually find out that their building is underperforming, not when they see the utility bill a quarter later, or that the financial department finds it out, but they will actually get a much earlier indication of what's working and not. And then also an example, I know they have some really sunny examples from in the beginning in one of their high rises when they installed water leakage detection. And within the first month, they have actually prevented 3 water leakage detectors, which one was about to be really, really serious. And I mean, and here, the thing here was that, I mean, due to that they were using, I mean, the standards, it was really fast for them. I mean, they were implementing this system, crossing them together with the spatial data really, really fast. So that was our use case.
Yep. Just one thing. We had a question from Fredrik online. We'll probably take that one at the end because it's a little bit technical. But please put the questions in the chat, and then we'll take them now if it's sort of relevant to the topic, or later if not. Yeah. So second case study is about Akademiska Hus, which is a Swedish, it's like government owned.
Yeah.
Yes, and they're responsible for a lot of the educational facilities in Sweden. They own a lot of the university buildings, that kind of stuff. So a massive portfolio over a large geographic area. And they've been using RealEstateCore for digital transformation, a lot of very interesting kind of projects that they're working on.
Yeah, and this is quite interesting. And I don't know, but I think I see also quite much examples. I mean, here from the US as well, that you can see that there's much universities that are doing when it comes to maintenance, predictive maintenance. I see the same goes here. Akademiska Hus is the governmental. They have roughly 35 million square feet of universities, usually quite nice building, old buildings, expensive buildings, and I mean, which there are kind of regulations for what they can do and not do in them, and high requirements on the indoor climate. And I know that the manager of one of those said that his big challenge was that they were kind of stubborn that no, we need to have them fully climatized from 8 o'clock in the morning till 8 in the evening because we have people there. I mean, no, you can't do any savings, so you're compromising the indoor air quality. I mean, they were really stubborn on that. I mean, when their first case, Akademiska Hus has actually been using RealEstateCore also for many years and also was one of the pioneers of doing the implementation between RealEstateCore and Brick Schema. And are working with this. But one of the first use cases was to actually see to convince their tenants that they didn't need more space or that they didn't need to have their premises climatized as much as they claimed. So they were let me see so I got the right one there, sorry. They were early adopter. Yeah, there we go. They were doing, I mean, the same kind of path. I mean, right now they are doing quite much work on standardizing with local standards. I mean, mapping to RealEstateCore Brick so they can consume the internal data that they have in different kinds of local standards. I mean, that's something that I've learned, that there are so many regional standards that you have so much information already encoded in that you have to take that. And as they say now, they have roughly 85% of their sites are being fed using RealEstateCore Brick Schema encoded data. And their first big use case was to enable data analysis. And then they have, I mean, there are plenty of different applications for doing occupancy analytics, as you might know. I think I've actually read a white paper by Jim a couple of years ago when you had gone through like hundreds of different IoT vendors for systems. So there's no lack of those. But imagine if you could reuse the peer sensors. You know, I have this kind of sickness when I go into a conference room or something. I'm always looking up in the ceiling and I try to count how many different peer sensors can I find. One for the ventilation, one maybe for the lighting, even might be some for the conference systems. I mean, it's not uncommon that you can find 3 different systems. And I mean, this will not work out in the long run. I mean, it's not sustainable from a maintenance perspective. So they were then figuring out how can we reuse the different kinds of occupancy sensors that we have throughout our different campuses. And that's where normalizing the data to RealEstateCore Brick was kind of a key component. And overall, they managed to, I mean, you have to bear in mind that even though they are a property owner that has clients, which happens to be the universities, they are not driven by maximizing profits. They're driven by maximizing the usage of the spaces. So they were managing to convince their tenants to, you don't need more space. Look here, we can see that you are underusing the spaces that you have. So they actually managed to increase the space usage with 4%. I mean, they're claiming that they're saving 3 million square feet because they have a huge portfolio. They're building more universities. I mean, the university sector is expanding, so they have lots of pressure to deliver more spaces. And this was, as they said, I mean, Ulf Davensjö, that's the chief business officer, that having this kind of being able to communicate this to the tenants was kind of the core, and also being able to do this cost efficient. I mean, due to being able to, of course, they could have taken all the different kinds of systems and just done some sort of mapping, but also being able to put pressure on the suppliers that they need to deliver their system and material in Brick RealEstateCore format was I mean, a big saver for them. So I think,
Yeah, those were the two use cases we're going to present today.
yeah, and more details of that is, of course, I mean, is of course in the white papers.
We can get on to the demos now in a bit. I don't know if anyone has any comments, anything they'd like to share. I think it'd be interesting to know if there's anyone in the audience who is also implementing Brick RealEstateCore. You know, if you want to share any comments, feel free to do that. And same online as well. Like if you want to put some comments in, and we can read them out. Let's move on then. So we've got I think some really interesting demos today. Most of them I think are kind of like around the same subject, right? Generative AI and RealEstateCore Brick, and how using structured data with generative AI is creating some really interesting use cases. So demo number 1. This is Gabe. Take it away.
Yes, great. So hi, everyone. My name is Gabe Fierro. I think that's our outline slide. So here, I'll just jump right into this. So first off, who here has used ChatGPT, or at least played around with it a little bit, right? So what's one of the main issues with that, right, is this issue of hallucination, right, where you're typing things in. It's really just a stochastic parrot, right? It's going to, they're optimized to give you something that you're going to continue to engage with. But they're ultimately, as an interface, I think they're extremely compelling because you get to interact with them using natural language, right? And I think this has been, I think, for a long time, right, the issue between the complex technology that needs to exist because buildings are naturally complex. They have a lot of complexities within them. The standards that we're using to describe how these buildings work, to present that data to software, is naturally very sort of it's naturally complex. It's naturally very detailed. It's designed for machine-to-machine communication. And so the problem is when you have a human that wants to interact with it, do you have to go and educate that human and train that human on how to learn all of these different technologies? And for many years, the answer was yes. Someone needs to just go and learn what that technology is, go learn the alphabet soup of technologies and protocols and programming languages to interact with it. And now the promise of generative AI is it might actually be possible for someone to express what they want in natural language, and the system goes and figures that out. And also the engineering effort required to do that could be dramatically lowered. So one of the things that I wanted to go and explore, so we have a way of, we have a brick model as a graph that represents a building. I can write queries, I can do that, but I've been doing that for many, many years. How do I get someone who hasn't spent that time in investing in the technology to be able to do the same thing? So one of the challenges we need to do for training one of these large models, we could go and train our own model. Of course, I've got just billions of dollars sitting in the back of my pocket, get a data center, get all of those engineers, go and train that model, maybe go and fine tune a model. But there's actually a much cheaper way. And so a recent a release, I think it was late last year, from one of the big AI companies, Anthropic, is something called the Model Context Protocol, or MCP, which you can think of this as it's a generic way that an LLM agent can invoke tools. And what's a tool? It's a piece of software that it can talk to. And so what happens is, and so I have my little Gen AI agent, which is in that box there. I have a set of these MCP servers. It's just a piece of software that's sitting on a network somewhere that has an API. It's just a REST HTTP API, like we've been doing for decades. And all it does is it presents, here's the things that you can ask me to do. I'll go through them, what they are for Brick, but basically the server says, here's what you can ask me to do. It presents itself to the agent. The agent receives a task from the user, and it decides how to accomplish that task given the tools that you've given it. And the thing that's so nice about this is that the choice of tools that you give it actually gives the agent a lot more insight into how to approach that problem. Whereas an agent, if I just ask, ChatGPT, how do I create a brick model for a building? How do I create a RealEstateCore model for a building? It's probably not going to have a great idea. There's a fair amount of documentation online, but it's not going to be good. It's not going to be able to validate it. You're not going to know if it's correct. You're just going to have to guess. and the MCP tools give us a way of handling that. So it's an easy and cheap way to make your agent an expert in a new domain, and tells the agent what the tools are available and what they do. So what are the tools for Brick? So this is where we take a hard right turn into the technical side. So we're trying to, hit all parts of the audience. Basically, and this is something that I, drafted up in a couple afternoons. There are 6 functions that the agent can call. It can list all of the concepts that are defined. It can list all of the properties and relationships that are defined in the ontology. If you give it a tag, it will guess the type. So you don't even need to have a brick model necessarily to get started. If you have a type, you can get what are the kinds of things, my entity can do. I can get a definition. And then lastly, I can also validate it. And what validation does is it then invokes this whole other, and I could talk for hours about the validation subsystem here. We'll talk a little bit about it at other sessions later on this conference. But basically, it's a way of telling whether or not the brick model is correct. Right? Does this match the standard? Is it in a compliant way that other people can use? So 6 simple functions. It's about 200 lines of Python code. It's open source. Download it, change it, whatever you want to do. And you can, with these 6 tools, you can actually use this agent for a ton of different things. You can do model creation, which is what I'll show in a moment. You can do question and answering. You can use it to build software. You can use it to interact with the building in many ways. And again, who knows, what you could do if you actually spend in some real engineering effort. But again, this was an afternoon and 200 lines of code, then I'm able to do this. So for the demo itself, the Wi-Fi is a little slow, so I'm not going to give a live demo. But if you find me later and I can tether with my phone, I can walk through it live with you. Basically, here's a mechanical diagram that I just downloaded off the internet. This is, if you Google BMS HVAC diagram, this is on the first page of Google image search. I was like, well, that looks pretty complicated and interesting. I wish I want to create a brick model of that. Right? I want to represent that system in a machine readable, digital, verifiable manner that uses the terms. It respects the connectivity, the topology of the system, includes all of the types, has the right labels in it, and the only input I have is that picture of that system. And the nice thing about the generative AI models we have now is they're all native image processing now. So they actually understand there's no more, if you've ever had to hire an engineer to dig up some ancient, optical character recognition OCR framework, probably Tesseract, and it's in C++ and it's the wrong version. You have to stitch everything together and you have to fine tune all the different knobs to figure, well, it didn't quite read the A correctly, or it's not reading the digits. All that stuff's gone. It really is upload this. I just click and drag into the Claude desktop app. I connected it up to my server running on my laptop, and then we're off to the races. So what happens? So first thing, so I'm really just taking screenshots from the chat. That's the extent of my demo. So I upload the image. It instantly recognizes, oh, I can Z cooling towers, chillers, air handling units, VAV boxes, secondary pumps. I see an expansion tank. If you go and look at the diagram, you can see all those things existed, right? And the first thing it starts doing, it says, well, I see these things in the diagram. Let me double check how those are expressed in Brick. And so those things where it says get definition Brick, it is calling, and you can see this when I zoom in, it's calling my server to basically retrieve the definition of that term. Right? There's no training here. There's no fine tuning. I wrote the server, connected to the agent, and it already has a sense of what kinds of questions it wants to ask. And what it's receiving back is a machine readable description of what that class is. What is a cooling tower? Well, there's the definition, right? And the definition's written in English text. And if I expanded this more, you'd have all the different rules, all the different constraints on what a cooling tower is and what it can do and what kinds of things it can have, which is the advantage of connecting this with an ontology. It's not just going and fetching data off the internet. It's actually retrieving a sort of template for what that information must look like in the model for other people to be able to consume it automatically. Right? So it recognizes the equipment types, retrieves definitions, calls tools as needed, and it's actually retrieving both RealEstateCore and Brick definitions because those are packaged in the same file. So the same 200 lines of code would work for ASHRAE 223P, they work for Brick and RealEstateCore, and they'd work for any RDF-based ontology. And so basically what happens is the model goes through this, it continues to define these terms, sometimes it can't find something it's looking for, so it asks to sort of guess for some other types, it makes some decisions about what to model, and again, the ontology is sort of informing what to do. And eventually it outputs the Brick RealEstateCore model. And here's a snapshot of the serialization of that model. The serialization, this is a standard serialization format, so we can just ship this off the network. You can read this in any programming language. And what it does at the end, it says, well, I built the complete model, and now I'll update the artifact, which is this text file, and now let me validate it. And so it takes that file and it kicks it back to my server, and my server checks the statements in that file against what's allowed by the ontology. I might say, hey, you used the wrong edge type here, or that's not a real class, maybe you misspelled something, or you should really have this annotation on this type so that people know where to find, what's the actual backnet label associated with that point. And it gives that feedback to the agent, and then the agent says, all right, let me go and fix that, and it will actually go in and do those edits. So that's actually just the end of my demo. I plan to do that live. But I have to say, for an afternoon's worth of work, I was incredibly impressed by the ability to be able to do that automatically. And you can actually augment this with additional functions. In fact, we already have some people from I think somewhere in Sweden, a startup in Sweden, contributing functions to my little MCP server implementation that's just on GitHub. So already, it doesn't even require that much technical effort to really engage with it. All you're doing is finding ways of presenting digital information to the agent in a way, and it's very powerful processing capabilities. I think this whole run probably cost me about a quarter, 25 cents worth of API calls. Yes. Oh yeah. So the question is, what was my prompt? Which is that's a very important question to ask. I have a prompt that's about a paragraph long. I will push it to the repository shortly. There's nothing proprietary in there. Basically, you tell it, create a brick RealEstateCore model that represents the system in this picture, and you tell it the things to do, like make sure you only use terms that exist. Use the tool to check that it exists, right? Add these information. Make sure you add labels to all the nodes. Really just telling it the requirements that I want. And I that's in there as a bulleted list inside the prompt. And so anytime I have a new thing that I want it to do, I just add another bullet point, and that costs me, I don't know, another penny. So yeah, great question.
Any other questions?
So it is just a.
Could you repeat the question just for
sorry,
people
yeah.
online? Thanks.
Yeah, so you're asking if this is using the ChatGPT API. It's not just the API, specifically because your agent needs to basically be able to pause its invocation and go and invoke other tools. So the model context protocol, something that the company Anthropic just invented, and other people have started adopting it as well. So I think it's now support in Google's LLM offerings. I think OpenAI is also augmenting its offerings. You can also do this with an open source model. So I ran this on a model on my laptop. The results aren't quite as good because it's only 14 billion parameters as opposed to however many trillions are behind the actual model. But you can get pretty good output just from a free model that you download online. The sort of the limiting factor, and I think this will start to appear inside the APIs themselves, is that the agent, at the point where it realizes, oh, I need information from that tool, it will basically emit a little special string that the software recognizes, okay, stop the LLM, go call the tool, get the results, give it to the LLM, and then resume generating. So you just need a little piece of code to do that, which you can implement yourself on the edge, but most of the cloud providers, I think, are moving to a place where you can just, I think companies are starting to provide MCP servers for their products, where there's just an endpoint online. You say, hey, by the way, right now when you use ChatGPT, it'll go and Google search for you. And we're getting to that point now where you can tell it what tools you want it to be able to use, and it'll just go out and find what functions it can call. So it's not quite as smooth as I want, but we're almost there. It's incredible. Yes, it's a huge step forward.
I thought there was a question at the back. Did someone put their hand up? You? Okay, sorry. I had a question. Are you got plans to update this work, or I mean, obviously it's open source now, but did you have any thoughts about how you might extend it?
Yes, absolutely. So thoughts on how I might extend this. So of course it'll remain open source. I'm an academic. I give everything away I do for free. If you have questions about it, you want to change, just email me, right? So I think for updates, I think the main thing for me is focusing on ASHRAE 223P. We'll talk a little bit about ASHRAE 223P later in this session as well as in future sessions. Where that model has a lot more detail in it, and it requires a little more effort to engage with. And that detail is necessary for machine to machine, but it's not necessary for humans. And so I think implementing additional functions that sort of describe maybe produce a visualization automatically. There's papers that can generate graphics automatically, so we might generate graphics automatically to emit pictures that explain certain parts of the system. Right now, we get it to the point where it can generate code that does things for you, like, hey, I know my model looks like this. Can you give me a fault detection rule that checks that these sensors are related? I have that code working. It's just not integrated with this, but we can actually get it to just generate arbitrary code that does whatever you want, that uses the metadata model to go and find the data. And of course, the challenge for a long time has been, how do you tell the model, what the right thing to do is? And now with the MCP server, we have textual descriptions attached to everything. And if I upload, this is something I did with some offline models. I just took a point list from guideline 36. So I have like the sequence of operations, and here's all the input and outputs you need to go and implement this. I just uploaded it to an offline LLM, gave it the MCP server, and say, hey, can you go write me basically a validatable specification that makes sure that my brick model or my building supports the sequence of operations? And it just spat that out. So, and then I can go and feed that in. Yes. Oh, yeah. It's just ChatGPT. So, yeah. It literally is just, I upload the picture, I paste in my prompt, and then it's off to the races. So I've done this with screenshots of BMS. I've done this with screenshots of sequences of operations. I've done this with screenshots of point schedules, equipment schedules. Not even pasting in the text. I take a screenshot of the spreadsheet. Mm. Yeah. I have not done that, but I think so. Sorry, to repeat the question is, if you had a very complicated mechanical diagram that's doing like, mapping between, terminal units, rooms, everything, how good is it at tracing those lines? I don't know, but I think that'd be a very interesting thing to try. Yes, no question. And against that, so the planned obsolescence of the software, of the hardware, and the it out saying, hey, outside software's going to pay. Yes. So I think that's an excellent thing for us to also follow up offline. This question of how do you plan for the fact that many things are capital investments? I think one of the benefits of these open standards, right, is that the information exists whether or not the provider also exists, right? Of whether or not there's someone there looking at it. And there's been so many times where I've gone into a building where the contract expired or the company no longer exists, and you have these digital assets that are basically inaccessible because it's some special protocol that that company developed. And our goal here and what we're advocating for is that with the use of open standards, that information is present in a standard form that you can always read, right? And maybe you don't get all of the smarts that you bought from the company, but you didn't lose any of the annotations. And so if someone else comes along and say, hey, I want to write some code that's going to go and continue to do predictive maintenance, maybe you go find some university student that's really interested in machine learning, they can do that. Now you don't have to spend, whatever that consultancy cost is to go and implement that. And also, they're not going to be knocking on your door asking, what does all that data actually mean? Because it's described with an open standard that's, got the documentation built in. So I hope that answers your question, but I'm happy to follow up offline as well. Yeah.
Great stuff. I don't know if there are any more questions. There's a few comments online, mainly saying good job, but also, just a comment here about an overview of MCP. There's a link here to a video, but also these slides, I've seen people taking photos as well. These slides will be available online as well on the RealEstateCore website.
Yes. Great. I hope I didn't go too much over.
So no, great stuff. Thank you. Where are we? Okay, so we're going to do the second demo. So Jason, would you like to come up? And again, I think we're going to, you're going to give your take on the similar subject, right?
Yeah. So, excuse me. I'm Jason Ko. I'm Chief Data Scientist at Mapped, and Gabe just showed how to utilize LLM to explore the ontology and how to convert the unstructured data into structured data using LLMs, conforming to Brick Schema and RealEstateCore. Now, I'm going to show how to explore that data, that structured data, through LLMs to actually get insights out of the data more easily. So at Mapped, we connect to all the different data sources and convert them into the normalized data and provide a beautiful GraphQL schema. And GraphQL is one of the query mechanism that is known to be developer friendly. And also it can federate all the different data sources that we support. And then it is an opinionated layer on top of the standard Brick and RealEstateCore. So if you look at the right bottom side, it is showing the graph. It is showing the relationships between the building, choose, and the zones, and you can represent that. If you want to get some of the insights out of it, you can use the left side query. It is looking like a JSON. It's looking like JSON, but it is simplified version of Brick terminology. So it is asking for buildings and things under the buildings and what that things are fitting, and in terms of the zones and what points are under the zone and so on. But as you can imagine, you can develop an application on top of it, but as a normal user, it is very difficult to write. So what's the desired mode of usage of such data for normal operators, building majors, or even the initial data scientists who want to know what the data, what kind of data is there in the building? So we want users to interact with the data through. We put some fun name, an ASHRAE. So like you can ask, what's the room with the lowest temperature in the building? Then an ASHRAE can explore the graph and get that retrieve the time series data and form the answer, and then actually give a human readable answer. Room 101 is the coldest with temperature 18 degrees Celsius. And this is now available at chat.map.com through our platform, and you can test it after registering at app.map.com. And I'm going to show more little details and how we did it. Our GraphQL schema is huge. It has like 6,200 lines of code, and we are also dealing with thousands of approximately 1,000 of Brick classes, including RealEstateCore classes. So to feed those into LLMs properly, we have to slice and dice, and properly enable search functions like what Gabe showed using tools. And then also look up the examples for generating something, and then summarize the ontology to feed them into the LLMs to know what they are actually looking for. And also, I'm going to show a little demo out of it, but we can actually generate the code using the GraphQL and the Python scripts for LLMs to analyze the building to know what's actually happening in the building. Yeah, we provide a lot of instructions on how they should do it. Also do the example lookup, and also we are running it in a safe sandbox so that it doesn't breach this security guardrails that your company has. And also it is we provide a lot of integrations through MCP. Gabe talked about a lot of MCPs, so I will skip what they are. But we are exposing those functionalities through MCP endpoints so that you can consume it through whatever applications you want. We have integrated with LibreChat. LibreChat is an open source alternative of ChatGPT. So you can even develop your own chat services using with this one, and you can plug MCP, our MCP, as a kind of a tools that your chat can recognize. So this is how the actual workflow in the architecture. So in the LibreChat, you can discover all the tools available in our Anaxi MCP, and you can log in through our OIDC map login, and then your token will be carried across the chain so that you can only access the data that you are allowed to access from our service. And in this process, you can use what kind of any kind of LLM providers, which is the kind of a brain in this case. So it is looking at the tool chains and choose what tool to choose and interpret the prompt and do the execution. And at that point, an XCMCP can access to map to GraphQL to retrieve the data and run the code to give an answer. So I would say it's pretty simple, and the map is abstracting a lot of complexity to it, and LibreChat is providing a nice chat UI to it. Oh yeah. Yeah, we have a booth here, and I also wanted to do a live demo because of the Wi-Fi issue. I took some screenshots from actual live chat. Come to the booth 409 tomorrow, Wednesday. You can actually test it. I'm gonna open a laptop and you can actually play with it, or you can log in here and do it yourself too. So here, I found that the text is a little small, but I can read the summary of it. Like I can ask, please list all the organizations that I have access to, and I have access to T90Works, which has a building simulator. It is a live building and it is keep running. And I'm asking to list all the buildings. It can say there's an IntelliCare infirmary, and on the right side, I can ask, show me all the images in the building, and it's running. It's actually generating the query and get the output and compile the answer and say there is an AH2 and an AH1. And what's the difference between discharge temperature and this set point in AH1? And you can, because it is a simulator, there's no difference at all, and it is 0 degrees Celsius. You can code up and get that answer. And can you plot them in the last 24 hours? And it is looking into the data, write up the code to generate this beautiful plot. And there's some glitch in those times, and now it is more visible, and you can actually ask any type of questions like this. You can ask like more geospatial questions. How many spaces do you have in each floor? And what's the average room temperatures in spaces in the floor, first floor? You can also calculate that and answer whatever questions you have. And yep, try it out yourself. I'd be happy to answer any questions.
So what that demo you showed, that people can go to chat.map.com and try it out for themselves.
Yes, but you have to register at that from first.
Question here, can I ask, would it be all right if I give you the mic? Because
Bring
then
your
people
credit
online
card.
can hear it, sorry.
It's my understanding, Jason, that you guys have extended, you have a recipe where you're putting together 3 ontologies, but you also have extended them. To what extent does someone who maybe is starting from scratch and is maybe not using your soup of the ontologies, what do they need to do to get the results that you've shown here?
You just need some structured API to retrieve the data that is normalized into whatever standard that you are using. We are using Brick Schema as an internal data model, and we are providing an interface of GraphQL to access the data, because we for developers to retrieve the data and query what they need. You can use Sparkwell, which is one of the standard ways of accessing the Brick models, or you can use whatever systems that they provide. So,
But your total ontology is a combination of RecBrick and ASHRAE, correct?
mostly Brick and RealEstateCore. Yeah.
Oh, I see. Okay. And so presumably though, you might have to make sure that you're also, the LLM is accessing ASHRAE, depending upon the type of detail, the depth that you want to go to in terms of the output, correct?
You're right. So that's it's hard. Yeah. So you need something like what Gabe said. Gabe provided. You need some endpoint that is providing an interface to the ontology as well, so that LLM can know what to ask to the actual system. We have our own implementation internally that is summarizing the ontology based on the prompt, so that we can our bot can translate more correctly from the prompts to the GraphQL, conforming to the standard vocabularies.
And I'm curious as well, Gabe, you've developed, my understanding, and I've seen it, is really great, is the motif of the building motif.
Yes.
And so is there a vision here where we could have a series of use cases that have a motif behind them? So here's a motif for whatever, ABC, and then the LLMs you already have a lot of the underpinning ontologies that are needed for the LLM to do its job.
You're right.
Yes, that's exactly right. So we'll talk a little bit later in the session, and then later in the C4SB smart building session, about the sort of the future role of how we see Brick, RealEstateCore, 223P working together. And of course, the building motif software development kit for creating and validating these models, we see as one possible sort of open API that unifies those capabilities across those models.
Mhm.
And indeed, right, I don't think there's one universal model for all of these. And so
Right.
the challenge is in make sure we use all of these things together. Brick and RealEstateCore solve very closely related problems. ASHRAE solves different problems. Project Haystack solves different problems. And making sure that you're using the right tool for the right standard for the right purpose, and making sure that they're all cleanly integrated, so that it's not a choice of what do you invest in, is you invest in that ecosystem, and then the automated translation between those takes care of delivering you the information at the level of abstraction you want.
Sorry, one more question. So I saw in one of the diagrams where IFC is represented. To what extent are you covering all of the data that IFC represents in your ontologies, or do you have to add to that? Do you have to give the LLM also tools, go fetch IFC data?
Yeah, I think it depends on the different types of use cases, and Brick was originally developed based on the certain types of application categories that we think that people need them at the moment, and by having a standard data model, you can have a kind of a summary of what you would expect from the actual data. And if we were to ingest all the IS data at once, I mean, even if you put all the data at once to the context of LLMs, it can be easily confused and then hallucinate a lot. So if
Probably
we
need
can
a separate agent for the IFC genius and the Brick genius and the Rec, and then they're all together, and then you've got the master, orchestrating all that, correct?
that's one way.
Yeah.
Yeah, and I can just add, I mean, the RealEstateCore is heavily influenced by the IFC, and I mean, Carl Hammar that will speak just in a couple of minutes. He's working in the building topology ontology group. I mean,
Right.
but I mean, when I've seen when it comes to IFCs is that of course you have the spatial part, but then when you come to all the details, it's get a little bit trickier. But I've been participating in projects where you have different kinds of usually regional standards for defining different kinds of technical equipment or other parts of the buildings in IFC as a property, and how you translate those into Brick RealEstateCore, that you make an alignment file for
Right.
that specific schema. So you
Right.
can consume, I mean, the vast information that you have in your IFCs, especially if you have like the MAP layers in the IFC.
Right. Great. Thank you.
Yeah. So just one final thing. The reason I put IFC on there is because there are efforts to represent IFC as an RDF model, so we can just interact with it using my same chatbot. Our goal is not to replace IFC or replace any sort of BIM, but rather to federate with it. So when you do need questions about geometry and these spatial questions, that like you can go and answer that from the source data and interact with it when we need to.
While I'm here, any more questions from the floor? Nope. Okay. Let's see if there's any online. Hang on. Let's have a look. There's a question here. Maybe this is a general one, but we can take it now. How do you compare a world where each vendor, such as Honeywell, Schneider, creates and promotes their own MCP server versus the ontology having a single MCP server to bring data in? And that question's from Michael.
I'd like to get a better understanding of what they would provide, but if they were to provide a similar functionality like this, there can be just a federation layer who can collect the data from different sources to compile the answer to give to the end users. But the reality is, to implement that, they will need some standard, whether it is an open standard or the internal standard. I cannot tell that for now. So that they can link up the human intents to whatever the data that they have in their databases. So if they abstract, if they could abstract with the MCP in subsector, which can be combined with that other ontologies or MCP servers before long-term integrations.
The only thing I'd add to that is I don't think there's any need to standardize on the MCP servers themselves. The ontology itself is the integration layer, right? So however that MCP server wants to work, whatever functions wants to provide, however you implement it inside, at the end of the day, if you produce a Brick a RealEstateCore model, then you can interact with anyone else that supports that, and however that gets produced, verified, interacted with. That can be your own sort of proprietary secret sauce, as long as the output of it is compliant with the standard.
Right. Jason, anything else?
I'm good.
Good. All right. Anyone can go and see mapped booth 409. Is that today or tomorrow? Right. So now we have the third demo about MSC Copilot Studio, and this is going to be given by Carl Hammer, who is actually online. So I hope we can bring him up now.
Hello, can you all hear me well?
Yes, we can hear you, Carl.
Excellent. So, sorry that I can't be there on site. Miss you all very much. And let me, I suppose, share my screen then. There we go. And oh, I'm telling you too much already. Mea culpa. Right. So, my background is I co-created RealEstateCore along with several other field folks, including Erik Wallin, who's on stage. And I wrote some research papers about it as part of my postdoctoral project. But I've since moved on now, and I'm working at Microsoft on the Copilot Studio team. And I'm going to be showing you a couple of use cases for how you can practically plug together a RealEstateCore compatible API with Copilot Studio to get you to an agent very quickly, very easily. And some of these things that we'll discuss touch upon questions that the audience had, so nicely teed up there, everyone. The building we'll be querying data for is the Euphemia offices in central Oslo, which is a real building, so we'll be pulling live data, hopefully. And it just happens to be the building that Microsoft's Norway offices are located in, so that's a nice synergy there. I'll be doing 2 use cases, one being a room finder for tenants, so put it in Teams or Microsoft 365 Copilot or what have you, where your office workers can effectively say, okay, get me a free conference room, something like that. And that will be pulled from the building graph. And then I have an autonomous agent scenario, which is actually perhaps a little bit more interesting in the long run. Before diving in, though, I just want to mention what is Copilot Studio. So it is our low-code, no-code solution for business users to create agents. And so the typical use cases would be like you can add your own knowledge sources and tools, much like both Gabe and Jason have discussed and showed. You can add tool calling to your agents to have them perform tasks for you that are specific to your use case and your organization. And Copilot Studio is admirably simple in allowing you to add that through a drag and drop style interface, very friendly for business users. It allows you to orchestrate multi-agent problem solving. This is also something that was touched upon earlier by the other speakers, that you may want, rather than to have one agent that does everything for you, it may be beneficial to have specialized agents that carry out the different tasks that have very clearly delineated and clearly defined instructions for what they do, and those are then orchestrated by a main agent that calls out to them. And Copilot Studio can do this for you. And Copilot Studio allows you to run your agents autonomously, and that's kind of crucial because you don't always want to be chatting with your agent. You sometimes want them to pick up the ball and run with it when an event happens, whether that's an event in your sensor systems, or it's an incoming request for quotes, or it's an incoming service ticket, or whatever it may be, incoming email, or a timer for that matter. You want your agent to be able to do the job without you having to be there to prompt it all the time. Copilot Studio has connectors for a broad variety of systems and data sources. We have MCP, which several of the speakers have mentioned already. We also have support for the Power Platform connectors infrastructure. So if you're already using the Power Platform, our low-code, no-code development solutions for business users, Copilot Studio can just pick up those connections and do interesting things with that data. And that's hundreds, or at this point, probably thousands of such connectors are available for any kind of system you can imagine. And then you can deploy this out to Teams, to Microsoft 365 Copilot. You can, if you're in the Microsoft stack, but if you're not in the Microsoft stack, you can deploy it also out to web apps, to Slack, to Telegram, to there's a whole list of publishing channels that's also growing. So it's a very convenient way of deploying these wherever you may need. I'm going to switch screen share to the demo itself and get you showing what I actually intend to show. Right, I'm going to jump in. And what I'll be looking at here is, this is a I will not be using MCP for this demo, as the previous speakers have done, though Copilot Studio does support that, and I'd love to have a discussion on how we can surface RealEstateCore through MCP servers. But instead, what I have effectively done is I've added a tool to my Power Platform, which is called RealEstateCore. And this is effectively just a JSON API definition. And this defines the API that we're using for the service that we're calling to get the data out. We could just have used the canonically released RealEstateCore API definition, which comes with the RealEstateCore ontology. However, what I found in experimentation is that if you have a open-ended API and you provide that as a tool to an LLM, it tends to hallucinate more. What I mean by that is, if you have all sorts of filters you can do and all sorts of pagination you can do, and you've defined a very competent and broad API, the risk of a particular field getting miscalled or getting wrong data put into it by the LLM is non-trivial. And the more fields you have, that risk obviously grows. So what I've effectively done is I've slimmed down the public RealEstateCore API and rewritten just the functionality that I need. So this is a small subset of that get rooms, get sensors, get latest sensor observation, get room geometry, and get all sensor observations. And this was a bit of work to do this, maybe an hour or so of writing this file. But nicely, the thing is, once I've done this, I can share this, and anyone in my organization who has similar problems or across the internet can just reuse this and immediately get Copilot Studio or other tools to pick it up. So let's now jump into Copilot Studio then. This is the front-end GUI. You can create agents by actually writing what you want to do, or you can, or there's a step-by-step wizard. And I pre-created a tenant assistant agent here. And let's load this up, and I'll show you what happens under the assumption that it loads. There we go. Sorry, it took a little bit of time. So we have the name. This is what shows up in the publishing channels, like my chat and so forth. I have a general set of instructions here. I have the actions or tools that I've added here. I'll get back to the general instructions very shortly, but what you'll notice that each endpoint in my API definition here, get rooms, get sensors, get latest observation, and so forth, end up as being an action or a tool inside of Copilot Studio. There's one that's missing here. You'll note get buildings because I didn't need it for this scenario, but I could add it by clicking the add action up here. But by making them available as a Power Platform connector, they're also made available to Copilot Studio. And let's then look at the instructions for how to call this. So these are my instructions to the LLM. You're an agent that helps office worker access data about their working environment by calling and collecting responses from tools provided to you. Okay, so far so good. When needed, you can and should make multiple calls to those tools to connect the resulting data together to answer the user's queries. So I'm effectively saying, use the tools you have available, help your user answer their question. And then there's a bit of detail about how you should handle some edge cases here. So for the get latest sensor observation, that API returns a 404. And I don't want the agent to error out when that happens. So instead, I just say that you should not include that in your analysis or subsequent task. We're saying that we want to use SI units, so meters over feet. For presence sensors, we're saying it's a Boolean where 0 corresponds to no presence and 1 corresponds to presence. We have ID fields that are GUIDs, and those GUIDs are used to connect the different tool calls to one another. But we don't want to present them to users. We primarily want to present the name to the users because GUIDs are unfriendly. And that's pretty much it. And we've turned on generative AI orchestration here. This effectively means that the agent will build a dynamic plan based on the prompt on how it's going to be calling these different tools. So let's give it a shot and see how it goes. I'm going to list all the auditoriums that are available, including their names and sizes. And this is live, and it's LLMs, and it can go wrong because LLMs are not entirely deterministic. But yeah, that seemed to work. So what did we do here? Well, first we called the get rooms tool, and it figured out, okay, auditorium is the correct room type, and it filled that there. I've actually hard-coded the page and page size because I don't want to risk any flakiness there. And I know that I have less than the maximum page size of return values, so that's okay. That's a lesson learned I'll get back to in the takeaways, that you want to constrain the API calls as much as possible to have as little variability as possible. But notably, this is not something that was constrained or restricted in any way, but the LLM figured out that this field should be filled with auditorium when I search for rooms. It got some rooms back, and then it got the geometries for the respective room, and figured out the room identifier from the result of the previous call. And similar here. So that got us those 2 rooms. Yeah, that's nice. Let's do something a little more complex. And I shall just copy over from my server text file here, my prompt. See if this works. Now, note that I've not told the LLM what unoccupied means or what conference room means or whatever, and it doesn't know anything about the fact that I have the sensors that I have. It's going to go and figure this out by calling. And again, this one has worked in about 85% of the cases, so let's hope it works for the live demo as well. No, it didn't. That's a bummer. let me then just restart. This being LLMs, sometimes you get this non-deterministic behavior where it figures out, no, I don't know how to do that. And I should say that the system prompt that I built here and the way that I put this together was literally done in 30 minutes or so. So if I had an hour or two, we would probably get a more stable, if you will, result. But yeah, so just doing something, yeah. Getting all the different sensor observations. Sometimes I find it runs a second loop, so let's see if it does that or not. No, it didn't. Okay. So these are the unoccupied conference rooms based on sensor observations. So we got the rooms first. We asked for, it asked for a conference room, figured that out by itself. Got the sensors for the, let's see, yeah, here. For all of those rooms, this is a comma-separated list, and it figured out that it needs to look for presence. Okay, that's good. And then for each one of them, it went and looked, get me the latest sensor observation. And based off of that, it deduced this answer. And that's, again, with a 30-minute or so of work to get this done. In addition to setting up the API to begin with, which was another hour maybe. But still, that's 90 minutes or at tops 2 hours to get to this result. Compared with building a system to do this, it's an order of magnitude less. And I can publish this and go hit it in the Teams channel. This was an earlier error. Again, sometimes that happened. Or I can go to the Microsoft 365 Copilot and ask the same question. And it works rather well. I'm also going to show you the occupancy rate assessor tool. This is the autonomous agent, and it differs in the sense that I don't run it interactively. I let it run in the background. In this case, it's running on a 10-minute timer. Normally, you wouldn't run this kind of thing at a 10-minute timer. You'd run it at maybe the end of the business day or the end of the business week, depending on your need. But what does it do at that point? Well, this has a very clear set of instructions because this is solving one task specifically. It's doing exactly this in order. It's not a generic system prompt. So when you're started, you're to summarize the occupancy rate of our conference rooms using this method. So retrieve all conference rooms, retrieve the presence sensors, retrieve the presence observations between start time and end time. Start time and end time are sent along by that trigger I just showed you. For each room, count the number of presence detections and the number of total detections and divide to get the ratio, and then send an HTML email. Each bullet should be on its own line. So it has the tools that I showed before, but it also has the send an email tool, which is provided by Outlook. And we can go and have a look at the runs it's been running. Yeah, these are automated runs, as you'll see. You'll see that some of these are waiting for user approval. That's because my access token for the target system has a lifetime of 1 hour. In the real world, obviously, you'd have a token refresh, but I didn't get around to building that. So actually, every hour I need to turn this thing on at the moment. But that's a demo limitation. But looking at the run, this was the trigger that was run there. Yeah, get the rooms, get the sensors, get the observations, and then send out an email with the result. And if all this worked, I should have gotten an email. So let's go and see. Yeah, I have gotten emails. Apparently over the course of the past X time, I think I'm doing hour by hour basis. One conference room was heavily used and the others were not. And this is all running autonomously in the background. So let me jump back then to the presentation and talk about then what we take away from this. So by using standard APIs, we can have connector use. And by APIs, I don't mean only RESTful APIs. I mean also things like MCP and standardized APIs building on top of standardized knowledge representation models, i.e. the ontologies. We can enable data reuse and pretty much next to instant time to value. Again, took a couple of hours maybe to build this entire thing. But if I were to build a system and deploy a system to do this, it would not be a couple of hours. It would be substantially more. And the LLMs really accelerate the time to value here. Key takeaway is that this APIs need to be built and documented for LLM understanding. And we as system developers, or you as system developers, need to think on how to do that. So in your Swagger definitions, let's say, or your documentation, if those are derived from your models, you need to make sure that the fields and the class descriptions and so forth are written quite expressively to enable an LLM to understand what the respective fields mean. So take pagination as an example. A developer will look at pagination fields and they'll know how they work by effectively looking at the name of the fields. An LLM does not have that prerequisite knowledge necessarily. I would also say make sure you have the data available for that's a general sort of truism, but in one of the scenarios here, the conference room finder, it was a problem for a while that the conference rooms did not have distinguishable names. They had IDs and then they had sizes. Conference room, medium, small, large, I think they were. And so the LLMs would get them conflated, even though it had the GUIDs, because the LLMs are sometimes very smart and sometimes not. So make sure you have the data needed for the LLM to perform its task, not just the task that a human would need, or not just the data that a human would need. I would also say, you need, while enabling the problem to be solved, you need your API to be expressive enough to solve the problem, obviously. But with that caveat in mind, your endpoints should offer as little variability as possible, because every field you can tweak will be a chance of hallucination, will be a chance of error, and that will grow the more fields you have. So have as small of an endpoint as possible. Doesn't mean your API has to be necessarily small, but each individual endpoint, which is called as a tool, should be as well defined as possible, and return as little data as possible while still being able to solve the problem. A challenge here is that you very easily run into token limits or context windows limits if you have more data than the LLM is capable of handling. So make sure to have well-defined sort of reasonable sizes of your data. And then most importantly, or not most importantly, but also importantly, task-specific agents. We touched upon this before, both I mentioned it and I believe it was mentioned by the audience. I showed you two agents here. The spatial utilization, the second, the autonomous agent, that was initially built as part of the first. They were built as one, and it worked really rubbish. Not at all. By breaking it out and giving it its own very clear delineated instructions for what it should do and how it should do it, that became much better at solving the task with very clear instructions for a particular task. So what you'll want to do is, if you have a large complex problem that involves several subtasks, is you really want to write several sub-agents that are each specialized for their part of the problem, and then you want to have them called by a main orchestrating agent that calls out to the others to fulfill the partial problems. But that's my takeaways from this. I hope you found it useful, and you're most welcome to try out Copilot Studio, and you're most welcome to reach out to me if you have any questions about how you can do that together with RealEstateCore Brick. And thank you. And I'm not hearing the microphone there now, Jim.
When we saw your last demo and conference room, I guess I know since it was live data and it was from Europe, so I guess it was like 5:30. So I guess that was a signal that the majority has went home.
Yeah, so
because that was live data that we were looking at.
Yeah, so when I set up this demo during the weekend and ran this, they were all at zeros. And then early this morning, when I did my dry run prior to presenting to you guys, I had 25% utilization over the past hour. And then now there's one room I think was occupied and the rest were not. So I think they've gone home for the weekend. I could give it a try and ask for presence across the building as a whole, but when I've done that previously, it's flaked out on a couple of occasions because there's so much data that I hit that context window limit. So yeah, but technically, I mean, you would be able to. The data is there. It's just difficult to.
And I would imagine, Carl, I mean, when you're looking at, I mean, setting up that agent, I mean, now it was an example for occupancy, but I mean, when we're looking at predictive maintenance, I think that would be, I mean, that would be probably my first thinking of use, having that monitor different energy consumers or other ventilation systems or other parts. And then you would, if you would then consume it in an email or Slack or Teams or wherever you're consuming it. Yeah, no, I think really
Yeah.
interesting to see here that we had like an academic version, then we had a startup, and now we had a big company solving the same problem.
Any other questions for Carl? Are you, Carl, are you hanging around, I guess, till the Q&A session as well? So maybe there'll be questions at that point.
Absolutely.
Good stuff. Right. Can we go back to the presentation then, please? Good. Okay, so we can move on now to, I think it's like the penultimate part of this from the technical committees, and then after this we can move to the Q&A session. Yeah. So, Eric, is this your bit?
I can start with this one. It should actually have been Peter. Unfortunately, he had some family engagement. Peter Hartlev is the chairman of the technical committee of RealEstateCore, and this is a mixture of both Brick and RealEstateCore technical committee updates. But first, little RealEstateCore. I mean, we used to say that. I mean, of course, we always get lots of good examples of improvements that we can do to RealEstateCore and Brick Schema, but at the same time, it's actually starting to be quite mature. It's being used quite much by many different property owners, and of course, we'll be the first to admit that there's lots of room for improvements. But still, I mean, what we are focusing on quite much right now is of course continue to align and converge standards together with our friends, not only Brick and ASHRAE, but and Haystack, but with others as well. We have also been running into the last year into taking a decision that we will start moving over. Now, initially, RealEstateCore was modeled using OWL, and then we went over to do DTL first. And now we are planning to go to OWL Shackle first. And this is one way to actually harmonize with Brick Schema and ASHRAE, so it will be even easier. I think we bumped into that. It was quite, the actual tool chain was quite complicated, and it took a long time, and it was so this is just one thing. If you're not into ontology development, it doesn't really matter to you, but just for your knowing that we are kind of simplifying this more, aligning it much more with ASHRAE and with Brick Schema. Another kind of really happy news is that we have started a new technical subcommittee in RealEstateCore for lighting. And I have gotten this question many times from different domains that come to me and say, lovely, RealEstateCore is great, but we're missing our domain. We need details about waste management or some other intricate part of running buildings. And we usually try to reply, well, RealEstateCore Brick Schema is a big work sharing project. I mean, we are not consultants. You can't ask that. We can help with the kind of ontology design parts, but not really about your domain. So with the lightning committee that just started, with Fagerhult Group is spearheading that. That's a big manufacturer of lighting equipment, and there's actually a couple of other big ones coming in. We're just giving our advice that if you need 200 different kinds of tags or data points for produce a lighting fixture and the control systems, well, RealEstateCore Brick will probably not standardize those. We will be focusing on which 20, especially RealEstateCore, will be needed for a property owner to run and maintain these lighting fixtures and systems for the upcoming 20 years. Which out of those are interested to them? Those are the ones that we try to put into the RealEstateCore standard. So that we're really happy to have Fagerhult on board of that. then we are also continue to extend. I mean, we have been doing a procurement requirement. We get the question many times from what system should I buy? What kind of requirement should I put on when I'm buying and making a procurement process? So also together now with Brick, we are kind of speeding this, or I mean, accelerating or going deeper into this into the procurement documentation part. The tricky part with procurement documentation is that it's extremely regional. I mean, you can't even say that it's national. It's actually regional. You have different kinds of requirements from the government or for different building codes that makes it really hard. And I think I will then leave it to Gabe.
Yes. All right. So I will also, I know we're eating into our Q&A time a little bit. So just some updates on Brick. We're moving to much more rapid point releases. So we've done the last few point releases all in the last sort of 6-month window. And our goal is really just to respond to community requests much more quickly, to be able to respond to that and fix what people need fixed. We also have an integrated build process. So we mentioned sort of the move to Shackle. So Brick, RealEstateCore, ASHRAE 223P, QUDT, a bunch of the ontologies now in the building space are all using essentially the same tech stack under the covers, which means they can all be supported with the same software. Which is it's fantastic. The details of that I can bore you with after this session if you were truly interested. Brick and RealEstateCore are now distributed on in the same file. So on brickschema.org, if you download brick.ttl, it's got Brick and RealEstateCore all packaged together. We also have some downloads that include QUDT. And if you are interested in ASHRAE 223, all those downloads are also on open223.info. We're also upping the amount of validation we're doing for future releases now that we're getting feedback from people that are incorporating Brick and RealEstateCore into real products. Sometimes little bugs have slipped by in our distribution process, so now I think we've stemmed most of those up. We're catching those bugs before they show up in products, and those things are validated in the actual release of Brick. We're also pursuing deeper integration with existing ontologies. Of course, RealEstateCore support for Brick remains first class. We've ripped out all of the overlapping classes from Brick. They sort of exist now as basically a pointer to the RealEstateCore concept itself. So the goal is not to compete, but to complement. ASHRAE 223P development has finished. We're just waiting on some votes from those committees to finalize some things up. So we have some initial integration with ASHRAE 223, but we'll be, I'll talk about this in a moment, investigating a much deeper integration with that, the ASHRAE 223 ontology to make sure that we're fully compatible and that it makes sense when you would use one over the other. As well as support for QUDT's new V3 ontology. We had a bunch of these different quantity kinds of different kinds of substances and things you'd measure in buildings. We had to go and invent a bunch of those. Now those are basically all gone. QUDT has basically reached feature parity with all the things we needed to model inside buildings. So we can just use that as an open standard to model all of the units, the data types. Unit conversions are all automatic through QUDT, which is a fantastic advancement as well. IFC-LD is a new effort to support RDF encoding of IFC models. One of the people heading that up is Dr. Dennis Sheldon at RPI in New York. And this is still early in development, but the IFC committee and Building Smart are aware of it, and it seems something that they're very excited about. And we're excited about that too, which means you could integrate that information into your Brick and RealEstateCore models in the future as well. Wanted to just touch on a couple things that we're doing on sort of the researchy side. One of these is new programming models. The RDF linked data community has had query languages and protocols and all different ways that you can interact with it, but they're not the kind of thing that you necessarily learn in a university class. And so one of the things I've been working on is, can I just write Python code to do a lot of this stuff? And the answer is yes. Here is it's the 8-bar rule 1. So from an old publication from Steve Bushby, where they did a bunch of FDD rules for air handling units, and I just implemented it in a couple lines of Python. And behind the scenes, the system takes care of accessing the Brick model, discovering the data sources, connecting those up to the Python function. It actually will generate new Python functions depending upon the availability of data. And so the development experience is extremely simplified. There's no custom programming language. There's no custom toolchain. It's just Python. And you give it to the runtime, and it takes care of the rest of that. We've been doing this on FDD rules. working with a PhD student at Carnegie Mellon University to maybe do this for some of the ASHRAE 231 control sequences work as well, which I think would be very exciting. And this is a step towards this dream of portable applications, which we've been slowly working towards for years. Another piece of research that we're doing is automated model generation. So just being able to scan out from your network. We have a little machine learning model that sort of learns your naming convention, figures out what different parts of the naming convention correspond to in terms of Brick and RealEstateCore, and then it uses the ontology to basically assemble the graph automatically, validate it, and then use the feedback from how that graph validates to be iterate over and over until you've got a functional Brick model. We're building this on top of Building Motif, which is something we've been building at the National Renewable Energy Laboratory. It's an open source software development kit that it implements this workflow as well as does validation, with the goal being that you should be able to, well, I guess I have it on the next slide. But yes, we can create these models automatically. We're doing it for Brick and 223, and we should be able to do it for the RDF version of Project Haystack as well. Another thing that we're really focusing on this year is semantic model validation. The idea that I should be able to, as Eric just mentioned, I should be able to specify the delivery of a semantic metadata model as part of a contract or an RFP process. And you're starting to see that language now, but it's basically stops at, can you give me Brick? Can you give me Haystack? Can you give me 223? But what does it mean to deliver that, right? And unless you're hiring someone who's also a services provider, there's not really a whole lot of reason why they would go in and double check all of that work. They're just going to deliver what's inside the contract. And so now what we're doing is these metadata validation requirements. There's actually a little executable document that specifies here's what metadata needs to exist for all of my fault detection control sequences to be configured automatically. And when the model's provided in a standard format using a standard ontology, we can just run it through the validation process. It spits out a report. That report tells you, here's what you need to go fix. Here's what's missing. Maybe you need to go buy a new sensor. Maybe something needs to be tagged differently. Once that validation process finishes, then you can go and start generating your control sequences and FDD rules, mostly automatically. Again, there's a variety of ways of doing that, and I can talk your off about all the work that's going on there. And again, we're building this on top of that Building Motif platform that we've been developing. So one last thing. So now that 223 is out, so one question we've begun asking ourselves is it time for Brick 2.0? So we first did Brick in 2015. We did a major rewrite for Brick 1.2 a couple of years later. We moved into the shackle space for Brick 1.3. We did RealEstateCore integration in Brick 1.4, and now ASHRAE 223 has come out. And so now it's an opportunity for us to say, what can we give up that we, did, 6, 7, 8 years ago to now play better in the new ecosystem that has emerged, right? Brick was never, from my perspective and Jason's perspective, Brick was not something we wanted to go and create. It's something we created because nothing out there existed to solve those problems. And now that ASHRAE 223 is out, it's an opportunity for us to revisit our old design decisions. Can we be 223p first? Can we make sure that every single concept inside Brick or RealEstateCore is rigorously defined in terms of the ASHRAE standard? And focus on what's the value add of Brick and RealEstateCore above the sort of a detailed 223 model. And so one possible vision of this here is that 223 is really this universal substrate that hopefully begins delivered with your OEM when you buy your equipment, you buy your controller, it comes with 223. This is extremely detailed. It has, all of the topology of the ducts and the ins and the goes in-as and the goes out-as, and the I/O points and the sensors and what properties being observed. Is it direct or is it remote? You have all of that detail if you need it. A lot of use cases, I maybe don't care about that. Maybe I just care about point labels. Maybe I just care about equipment topology. Maybe I care about space usage. Or I care about, real estate value being delivered. And so things like Brick and RealEstateCore and Project Haystack can exist as layers on top of ASHRAE 223, whereas an investment in the 223 standard means that you also can get the benefits of Brick, Haystack, RealEstateCore automatically as programmatically derived views on top of that. And then whatever platform you happen to buy and whatever they happen to support, you have the ability to sort of connect through a standard representation of that metadata so that that platform can find what it needs. And so the vision here, which, I think this is our call to the community is like, what more do we need? What problems do we need to go solve to realize this vision where, these different products can compete on their capabilities and not on what labeling scheme they happen to use. I think there's a lot of exciting work being done in this space. We are auto-generating simulations. We are auto-generating control sequences. We're connecting things up to LLM agents. And all of this is enabled by agreeing on how we want to represent information, right? That's not where things stop. That's where things start. And so we hope now that ASHRAE 223 is out, that this is the beginning of a new direction for us all. So please keep an eye out for Brick 2 and RealEstateCore 5. This is the things that we'll be working on in the coming year. All of this stuff is community driven. There's no benevolent dictator. It's an open source GitHub repository that you can commit code to. You can raise issues. You can come and talk to us. I have a Brick office hours. I'm in a Zoom session for at least 15 minutes, a few times a month. Just come and talk to me. Send me an email. This stuff is driven by people coming and talk to us. We're all moving towards areas to make sure we can work better together, to make sure that all the hard engineering integration work is being done by us, and so the rest of you can really just derive value from the models. So please follow our work on GitHub, github.com, RealEstateCore, and github.com/Brick Schema. And one final thing, we had a chat service for RealEstateCore, which was like, no one was using it, so don't go there. Just go to the Brick Google group or file an issue on the GitHub, and we'll get back to you as soon as we can. Anything that you wanted to add?
I was going to say, Eric, do you want to maybe talk
No,
about membership of RealEstateCore? How people can get involved in it?
I think, as always, Brick or RealEstateCore, of course, you can always become a member. All code is under, now we also switched over using BSD, which is very permissive open source license, so there's no fees or anything. But please, if you want to contribute, it's a good thing to be members. To be able to be part of a technical subcommittee, we have that as a requirement, that you have to be a member.
So that allows you to get deeper into help driving the future of these standards.
Yeah.
And is there, in terms of as a vendor, what's the best way to get involved, or even as a building operator, owner of large portfolio, what would you recommend?
As a vendor, I think it also comes down to being part of influencing the standards. Because as we said before, we know some things about doing ontology design, and of course we know little things about building technology systems as well, but the real experts are the different domains that can help out with that.
I say the first thing to do is send us an email, come to one of the working groups, and we'll figure out what your needs are and sort of point you in the right direction. I think brickschema.org and realestatecore.io both have user-facing documentation, which are great places to get started as well.
There's a question here from online. Maybe we didn't explain this properly, but it says, a member of what? Can you provide more details on that? So.
Okay. You can apply to become a member of RealEstateCore and or Brick Schema. I think that's the best of the two worlds, to have dual memberships. So that is the member of. I've been given that question before, and I give the same answer. I think a dual membership would be great. I don't know. Maybe next year when we're standing here, maybe we have a combo special.
Yes. So both the Brick Consortium and RealEstateCore have 501, or for Brick, we're incorporated in the United States as a 501c6. I think you're. Yeah. Legal nonprofits. So there are opportunities to join as an industrial member, and for Brick, it's voting rights on what goes into the next version of the standard. Anyone can contribute anything, and also there's permissive IP licensing within that to make sure that patents don't get in the way of contributing information. And we have plenty of information on that on brickschema.org. I think it's /consortium, but there's a link on the main page for that.
Yeah. And the same for Brick.
Thanks, guys. I think that's pretty clear. But obviously, if people want more information, you can go to the website. So we've got a bit of time. How long have we got? We've got about 15 minutes if people want to ask questions. We have Carl, who is online. We have the guys here. These are some of the other people that are involved as well. So I'm sure if you go on LinkedIn, you'll be able to find these people. And again, if people have follow-up questions, I'm sure you can take those by email or whatever. So I don't know if anyone has something in the room. We've got a couple of questions online as well, but we can take anything in the room first. Yeah, 1 second.
First of all, just great work, guys. This is a lot. You put a lot out here, and wow, very exciting. So my question is, I've noticed that the DDO, Department of Defense in the U.S., has now mandated that all of their that across the board that they have to use the basic formal ontology, the upper ontology. And I'm curious as to, because we keep getting demand for the Rosetta Stone that covers the entire landscape of, I'm a property owner, operator, et cetera, et cetera. I've got data from many different sources. This is really rich, the inside of my building and some of the service aspects. But to what extent do you think at some point you may be the sub-ontology, the middle layer ontology, or the lower layer ontology feeding up into the BFO or the equivalent?
Yeah, I have complicated feelings about this idea of a Rosetta Stone. I think anyone who says they have a Rosetta Stone is selling you something. I don't think that exists. There's some great stories about the old days of ontology development where they were talking to researchers in Japan, and the upper level distinction was between things with souls and things without souls, right? And so big trees render things with souls, and small trees were things without souls. And in the United States, they were differentiating between things that were permanent and things that were sort of were momentary. So I think the challenge with this sort of really high level integration between everything is everyone has a different perspective on what they're looking at, right? Even within something like heat pumps, of like we look at heat pumps as like, oh, a heat pump delivers heat. Well, it's like, well, not if you talk to a physicist. A physicist doesn't really care which way the heat moves, but you do if you're in HVAC. And so I really do think that it's better for these ontologies to be relatively specialized in what is your perspective on the world, right? What is a sensor? In Brick, a sensor is not a physical sensor. It's just the IO point, right? It's like a backnet sensor. Whereas in other ontologies, a sensor is an actual physical thing, right? So I think our work here is to be specific in what we're modeling and what the perspective is and what those terms mean. And at the point where it makes sense to do that integration, that's where we can go and figure out what the details are. And so for ASHRAE 223, which does care about the physical placement of sensors within the environment, it's like, well, here's what that model looks like to use Brick and 223P in the same model, where the Brick sensor represents, here's where the IO point appears in the BMS, and in 223, here the sensor represents the physical transducer that's in the duct that's actually doing the measuring. So I think in some ways you can use this, things like BFO to sort of wrap everything up in these generic classes. But in many ways, for me, it amounts to type erasure, that you're, by seeking interoperability between things, you're losing the ability to ask specific questions. So for me, in my experience, I haven't been totally convinced of like a single universal ontology. If anything, I think the ability of large language models to incorporate the semantics and some of the domain-specific definitions provide us maybe the best avenue towards doing that we've had in decades.
So are you looking then to lean more on the taxonomy to support the ontology?
Or maybe I can add, I mean, in RealEstateCore, I mean, we have been driven that we should not care about anything outside the buildings. We will put an API on the buildings. And then on the other hand, we are working quite close with FiWare, which is the NGSE LD, which is probably one of the largest smart cities and smart agriculture, smart grids, everything. And we are just trying to align with them and making sure that when we are interacting with some smart city ontologies, then they understand our language and can use that when the buildings are interacting with the grids or other parts. So I think also it's kind of, it's quite hard. I also remember in the beginning of ontologies when I started actually to do working with it in academia. I mean, it was also much more upper ontologies that you were doing in domain specific. Carl Hammer could probably tell tons of stories about this, but I'm also a little bit more pragmatic in seeing that make sure we have very well specified APIs on the buildings, and then we interact with whatever smart cities or smart grid ontologies there will be out there.
And maybe sort of one final thought. I think the move to shackle as the constraint language, I think reflects we're trying to think very practically about how do I express the information I have, rather than trying to fit a very complex and organic world into a sort of formal set logic kind of thing. And so we're very, I think, specification driven for this, but I think we're on the cusp of a very deep dive into this. I'd love to follow up with you.
Well, lots more questions, but I'll give someone else a chance.
Yeah, sure.
Since I heard my name
But yeah, is
mentioned,
anyone else here?
There was a question online early on. That
There was,
technical.
yeah, we can take, oh, we'll come back to you, yeah. If you,
Oh,
oh, was there a hand? Where was that?
I thought. Oh, you.
The one online, let's have a look. There's one here about recommending low-code tools with graphical user interface for semantic modeling. If you have no Python or shackle coding knowledge, I know we've kind of discussed Microsoft Copilot. I know there are other workflow automation tools, which are pretty cool. You can take in different APIs, and they also have built-in functionality. But do you guys have any recommendation for low-code tools?
I have not used any low-code tools, but I would say that with the MCP server, the things that Jason showed, what I showed, and then the Copilot Studio as well, are all ways that you can interact with in a low-code way, just by interacting with text. And my demo, where I even if you just start up with ChatGPT, say I'm going to start creating a brick model. I want to add this information, that information, write a query that gives me this information. It'll do a fairly good job. And the addition of the MCP server makes that more robust.
I say shamelessly, Map is a product for no code normalization.
There you go.
Yeah, I don't see a open source full stack no code data normalization tools, but we do offer. We actually gonna announce those tools as a service as well on top of our normalization at pipeline. So you could try that too.
Okay. The question from earlier is reasonably technical. What is your recommendation for how you name meters out in your buildings? The names of energy meters become long and they aren't really compatible on, for example, an operating card, HVAC overview.
I can take a little bit that I was working with the codices. I mean the underlying, I can't remember the ISO standard for PLC programming. I mean which many are using. And when we did that many years ago, we tried to set a standard for a large property owner, and just figured out, I mean, the limitations of doing variables in programming in the codices programming language. And again, also when you have blueprints or you have name tag, you have tags between, if you have like a room controller or something similar. I've gotten this question many times, and I've seen almost as many property owners there are. You have different kinds of tagging standards for this. I can't really say that I have any favorite, but I know it's different. It's different between different countries, and it's different between even local regional. So I don't have any super good. Probably look into something that your suppliers are working with.
My advice would be that I think our goal largely is to move away from naming conventions, right? And is that the graph represents that information in a structured way. And so however you happen to sort of summarize that information in a text label is whatever, whatever is useful for your facilities. But ultimately, the way that you represent that information is by, well, it's a graph, right? And so if I have multiple meters and I have submeters, and those are connected with submeter relationships, and if I have specific monitoring on specific pieces of equipment, then that's another edge in the graph that relates that meter to that. And actually, on the Brick website, on our documentation, docs.brickschema.org, we have examples of how you write queries to avoid double counting. If you've represented that submeter hierarchy in a way that's compliant with Brick. So that would be my advice, is to move towards structured representations of the submeter hierarchy to try to sidestep these questions of, well, what do I name something that's 5 layers deep?
Put UUIDs on everything and have QR codes out for the staff.
Jason?
We do want to represent everything in the graph, and I think eventually people perceive things as graph anyway. But in reality, there are device limitations. If we want to encode everything into a device, sometimes it is required to put some information inside the names. We totally get that. Brick, we had a long time ago some effort about serializing a part of the graph as a name, so that you can have more standardized way of representing the types and relations in names, so that we can encode that. I believe there was an open source project from a different group on that too. Gabe, do you recall what the name was?
Yeah, W3C had the building device naming standard, BDNS work. I think they're still active.
Okay, we've got a few minutes left. There's a couple of questions here. So maybe we could take your follow-ups offline. Sorry about that. We're running out of time. So first one, as you think towards the future, how do you see ROI evolving? More ROI in the same domains, or ROI expanding into new domains?
We discussed a similar topic last dinner, actually. So let's say that you are investing on some HVAC solutions and you need a lot of data for running that specific application. And when you start normalizing the data and transforming those into an ontology, you need to know whether this specific point is falling into HVAC or lighting system or something like that. So at that point, you already put a lot of effort in normalizing the entire building. And after that, you will get for free, like lighting applications or occupancy applications and so on. So normalize, and then also, probably you have normalized the geospatial information for HVAC systems, because you want to know whether a room is occupied or not for optimizing the energy efficiency. So what your ROI by investing on this effort for data normalized for a specific application will, double up, triple up across the next applications that you are gonna run on.
Just one, or did you want to add something?
Oh, I think the thing I would add is that I think it makes a lot of the investments more transparent. And I think one of the things that we hear a lot is that it's like, oh, well, we bought this smart, plumbing system or domestic hot water system, and they have their own sensors, and so they need their own gateway, they need their own integration. Anytime you get another sort of third-party, add-on that have to do their own integration, have to do their own tagging, the rest of it. And I think what happens gets lost in sort of the build and the specification and the construction and the commissioning process is, well, what data did I buy and what sensors did I buy and how are those actually getting used? And the way that you trace it is by following through your 300-page BlueStack PDF with all the annotations, and multiple versions are getting mailed around. And so I think right now investment in these open standards makes your investments more transparent, because if I bought that sensor, how is that being used? Who is using that? Do I actually need that sensor there at all? What future applications would be enabled if I were to make that sort of investment?